From the dawn of humanity, we've gazed upon the sun with a mixture of awe and fear. It's the ultimate source of energy, bathing our planet in light and warmth. Without it, life as we know it would cease to exist. The sun isn't just a static ball of fire, though. It's a dynamic, ever-changing celestial body capable of incredible displays of power. Like a beating heart, the sun pulses with activity. Its surface churns, flares erupt, and vast streams of charged particles hurtle through space. For the most part, Earth basks safely in the sun's radiance, shielded by its magnetic field. But sometimes, the sun unleashes a fury that can reach across the vastness of space and touch our planet. These events, known as solar flares, are a reminder of the immense power of our nearest star and the vulnerability of our technological civilization. While we marvel at the beauty of the aurora borealis, a dazzling side effect of solar activity, it's also a subtle warning of the potential chaos these flares can unleash. Announcement: SurvivalScope will be giving away a prize to 3 lucky subscribers from this video. Watch this video to learn more. Now, imagine a sudden surge of energy, 1 billion times more powerful than any atomic bomb, erupting from the sun's surface. That, in essence, is a solar flare. These intense bursts of radiation are like solar storms, capable of disrupting our satellites, communication systems, and even power grids here on Earth. Solar flares are not all created equal. They are categorized based on their intensity, with the most powerful ones capable of wreaking havoc on our technology-dependent world. In a world increasingly reliant on interconnected systems, the impact of a major solar flare could be catastrophic. Understanding these solar tantrums, these powerful flares, is crucial to protecting our way of life. By delving into the science behind solar flares, their history, and their potential impact, we can begin to prepare for the day when the sun next unleashes its fury upon Earth. Join us as we explore the world of solar flares, their potential impact, and how we can prepare for these celestial events. To truly grasp the danger posed by solar flares, we must first understand what they are and what causes them. Imagine the sun's magnetic field lines as a series of intertwined loops, like a giant cosmic knot. These loops are constantly shifting and interacting, storing immense amounts of energy. When these magnetic fields become too tangled and stressed, they can snap and realign in a process called magnetic reconnection. This sudden realignment releases a tremendous amount of energy in the form of radiation, creating a solar flare. Think of it like stretching a rubber band to its breaking point. The energy stored within the stretched rubber band is suddenly released when it snaps. This burst of energy from a solar flare travels at the speed of light, reaching Earth in about 8 minutes. The energy released during a solar flare is not uniform. It spans a wide range of the electromagnetic spectrum, from radio waves to X-rays and gamma rays. Each type of radiation carries a different amount of energy and interacts with matter in its unique way. It's this powerful cocktail of radiation that poses a threat to our technological infrastructure. Not all solar flares are created equal. Scientists classify them based on their intensity, using a lettering system similar to how we categorize hurricanes or earthquakes. The most common and least powerful flares are C-class flares. These flares are relatively weak and generally have minimal impact on Earth. Imagine them as the gentle breezes of the sun's activity. Next up are M-class flares, which are more intense than their C-class counterparts. M-class flares can cause brief radio blackouts on Earth, particularly near the poles, and might trigger minor geomagnetic storms. Think of them as the sun's version of a strong thunderstorm, capable of causing some disruption, but generally not widespread damage. At the top of the scale are the mighty X-class flares. These are the behemoths of solar activity, capable of unleashing the energy of 1 billion atomic bombs. X-class flares are relatively rare, but when they occur, they can have significant consequences for Earth. These are the sun's hurricanes, capable of causing widespread power outages, disrupting communication networks, and even damaging satellites in orbit. Announcement 2. The 3 subscribers must be from the United States or Canada. Now, The energy released during a solar flare doesn't just disappear into the vastness of space, it travels outward in all directions, carrying with it a symphony of electromagnetic radiation. This radiation, much like different instruments in an orchestra, interacts with matter in unique ways. Radio waves, the lowest energy component of solar flares, can interfere with radio communications, creating static and disrupting signals. Microwaves can heat the Earth's upper atmosphere, affecting satellite orbits and potentially causing GPS errors. Ultraviolet radiation can ionize the upper atmosphere, creating colorful auroras but also disrupting radio communications. And then, there are the X-rays and gamma rays, the most energetic and potentially damaging forms of radiation. These high-energy photons can penetrate deep into the Earth's atmosphere, potentially disrupting power grids, damaging electronics, and posing a radiation hazard to astronauts and high-altitude flights.
Section 1. The Carrington Event. In the annals of solar history, one event stands out as a stark reminder of the Sun's raw power, the Carrington Event of 1859. Named after British astronomer Richard Carrington, who first observed the massive solar flare that triggered it, this event remains the most powerful geomagnetic storm ever recorded on Earth. On September 1st, 1859, he was sketching a group of unusually large sunspots when he witnessed a blinding flash of light. Unknown to him at the time, he had just observed the most intense solar flare in recorded history. Within hours, a barrage of charged particles from this massive coronal mass ejection, a CME, slammed into Earth's magnetic field, triggering a cascade of events that illuminated the skies and sent shockwaves through the fledgling technological systems of the time. Imagine a world bathed in the ethereal glow of the aurora borealis, not just at the poles, but as far south as the Caribbean. Telegraph systems, the cutting-edge technology of the day, went haywire, spitting sparks, igniting fires, and delivering electric shocks to unsuspecting operators. The Carrington event provided a dramatic glimpse into the interconnectedness of the Sun and Earth, a celestial ballet with potentially devastating consequences.
Announcement 3. Eligibility ends after the 1,000 subscribers have entered. The impact of the Carrington event on the telegraph system was particularly striking. Telegraph operators across the globe reported strange anomalies, from systems operating without batteries to messages being garbled by electrical surges. In some cases, the electrical currents induced in the telegraph wires were so strong that operators could disconnect their batteries and still transmit messages, powered solely by the geomagnetic storm. While these anomalies provided a fascinating insight into the power of the aurora borealis, they also highlighted the vulnerability of emerging technologies to space weather. The Carrington event, in many ways, was a wake-up call, a stark demonstration of the Sun's ability to disrupt human activities, even in the 19th century. The stories from this era paint a vivid picture of the awe and confusion that gripped those who witnessed the event. Imagine the fear of a telegraph operator, suddenly witnessing sparks erupting from his equipment, the air filled with the smell of ozone, and the sky ablaze with otherworldly light. The Carrington event was a stark reminder that our technological advancements, while impressive, are still vulnerable to the whims of our nearest star. While the Carrington event occurred over 150 years ago, its relevance today is more profound than ever. In our increasingly interconnected world, where technology permeates every aspect of our lives, a similar event could have far-reaching and potentially catastrophic consequences. Imagine the chaos if our power grids went down for days, weeks, or even months. Satellites, the backbone of our communication and navigation systems, could be damaged or destroyed. Financial transactions, air travel, emergency services, all reliant on intricate electronic networks, could grind to a halt. The Carrington event serves as a stark reminder of the potential havoc that space weather can wreak on our technological civilization. While we might not experience another Carrington-level event in our lifetime, even smaller solar storms can still disrupt our lives, causing temporary blackouts, GPS errors, and communication outages. The echoes of the past serve as a constant reminder of the need for vigilance, preparedness, and a deeper understanding of the sun and its influence on our technological world. In the wake of the Carrington Event, scientists and engineers began to recognize the importance of understanding and predicting solar activity. Over the past century, we've made remarkable strides in space weather forecasting, thanks to a fleet of sophisticated satellites that act as our eyes and ears on the sun. These robotic sentinels, positioned millions of miles from Earth, constantly monitor the sun's every move, providing us with a continuous stream of data about its activity. Imagine these spacecraft as high-tech weather buoys, bobbing in the vast ocean of space, their instruments trained on the sun's turbulent surface. They track sunspots, those dark, cooler regions on the sun's photosphere that often serve as the birthplaces of solar flares. They measure the strength and direction of the sun's magnetic field, looking for those telltale signs of instability that could herald an impending eruption. These spacecraft are constantly beaming back a torrent of information about the sun's behavior, providing us with a real-time view of our star's every twitch and tremor. This data is crucial for space weather forecasters, who use it to predict the likelihood of solar flares, CMEs, and other space weather events that could impact Earth. The data from our space weather sentinels is only as good as our ability to interpret it. That's where the work of solar physicists like Dr. Jane Smith comes in. She and her colleagues use sophisticated computer models to analyze the data from space weather satellites, unraveling the complex physics that govern the sun's behavior. They study the evolution of sunspots, the dynamics of the sun's magnetic field, and the processes that drive solar flares and CMEs. Their goal is to develop more accurate and reliable space weather forecasts, providing us with as much warning as possible before a major solar storm heads our way. It's a challenging task, akin to trying to predict the path of a hurricane days in advance, but the stakes are incredibly high. Every piece of data, every observation, every simulation brings us one step closer to unraveling the mysteries of our nearest star. With each passing year, our understanding of the sun's behavior grows, allowing us to better anticipate and prepare for the inevitable day when the sun unleashes its fury once more.
Announcement 4. Prizes will be items featured in this video. Stay tuned. By understanding the risks solar flares pose and taking appropriate precautions, we can minimize their impact on our technological infrastructure and way of life. Governments and space agencies around the world are working together to improve space weather forecasting and develop mitigation strategies. Power grid operators, for example, are implementing systems to protect their equipment from the damaging effects of geomagnetic storms. Satellite operators are developing strategies to safeguard their spacecraft from intense radiation bursts. And communication companies are exploring ways to maintain connectivity during solar radio blackouts. But preparedness isn't just the responsibility of governments and corporations. Individuals can also take steps to protect themselves and their families from the potential impacts of space weather events.
Let's imagine a scenario, a hypothetical yet plausible event that unfolds in the not-too-distant future. The sun, seemingly calm in its celestial dance, erupts with a fury rarely witnessed by humankind. An X-class solar flare, a monster of energy, bursts from a sunspot cluster, aiming its wrath directly at our vulnerable planet. Within 8 minutes, the first sign of trouble arrives, a blinding flash of X-rays and gamma rays, invisible to the naked eye but detectable by our space weather sentinels. These high-energy photons slam into the Earth's upper atmosphere, ionizing the gases and disrupting radio communications. Almost immediately, shortwave radio frequencies fall silent, their signals drowned out by the solar static. Airliners crossing the poles lose contact with ground control, their navigation systems momentarily blinded by the solar storm. Meanwhile, the invisible threat is just beginning to reveal its true potential. Traveling at a slower pace, a massive coronal mass ejection, CME, a billion-ton cloud of charged plasma, races towards Earth at speeds exceeding 1,000,000 miles per hour. This CME, carrying the magnetic fury of the sun, holds the potential to cripple the technological systems that underpin modern civilization. As the CME slams into Earth's magnetic field, it triggers a geomagnetic storm of unprecedented intensity. The sky erupts in a dazzling display of auroras, visible as far south as Florida and Mexico. But this celestial light show is a deceptive beauty, masking the chaos unfolding below. The electrical grid, the backbone of our modern world, begins to falter under the onslaught of the solar storm. Transformers, those massive devices that regulate the flow of electricity across long distances, start to overheat and fail, their delicate circuitry overwhelmed by the surge of geomagnetically induced currents. One by one, power grids across the globe begin to collapse, plunging cities and entire regions into darkness. The sudden loss of power sends shockwaves through society. Hospitals struggle to keep life support systems running, relying on backup generators with limited fuel supplies. Traffic lights go dark, creating gridlock on already congested roads. Communication networks, already strained by the initial solar radio burst, begin to fail as backup batteries dwindle. The world, so accustomed to the constant hum of electricity, is plunged into a disorienting silence. Announcement 5. Rule 1. Must like this video. After it's all over, the true extent of the disruption becomes horrifyingly clear. The global supply chain, reliant on just-in-time delivery and intricate logistics, grinds to a halt. Supermarket shelves, emptied by panic buying, remain bare. Gas stations, unable to pump fuel without electricity, become useless monuments to our dependence on fossil fuels. Access to clean water becomes a critical issue as water treatment plants shut down, their pumps silenced by the lack of power. Hospitals, overwhelmed with patients suffering from heat stroke, dehydration, and chronic illnesses exacerbated by the lack of medication, struggle to cope. The thin veneer of order begins to fray as fear and desperation grip the populace. Yet, amidst the chaos, the resilience of the human spirit shines through. Neighbors help neighbors, sharing food, water, and information. First responders work tirelessly to restore order, their efforts hampered by the lack of power and communication. Engineers race against time to repair the crippled power grid, their task made more challenging by the ongoing geomagnetic disturbances. The road to recovery will be long and arduous, but the human spirit, it seems, is not easily extinguished. The fictional scenario we just explored, while hypothetical, underscores the very real threat that space weather poses to our modern way of life. A major solar storm, like the Carrington Event of 1859, could have cascading effects on our interconnected world, disrupting communication networks, crippling power grids, and jeopardizing critical infrastructure. But panic is not the answer. Just as we prepare for hurricanes, earthquakes, and other natural disasters, we can take steps to mitigate the impact of solar storms and build resilience in the face of these celestial events. The first line of defense is awareness. By understanding the nature of solar storms and their potential impact, we can make informed decisions about how to prepare and respond. Stay informed about space weather forecasts from reputable sources, such as the National Oceanic and Atmospheric Administration, NOAA Space Weather Prediction Center. These forecasts provide timely information about solar activity and potential impacts on Earth, giving us valuable time to prepare. Just as a ship's captain consults weather reports before setting sail, we too can use space weather forecasts to guide our actions. If a major solar storm is predicted, consider postponing non-essential travel, especially air travel, which is particularly vulnerable to communication disruptions. Secure loose objects outdoors that could become projectiles in high winds associated with geomagnetic storms. And be prepared for power outages, stocking up on essential supplies like food, water, and medications. Announcement 6. Rule 2. Must subscribe. Preparing for a solar storm isn't just about reacting to imminent threats. It's about building long-term resilience into our infrastructure and way of life. Governments and industries around the world are working to harden critical infrastructure against the effects of space weather events. Power grid operators, for example, are implementing systems to protect transformers from the damaging surges of geomagnetically induced currents. Satellite manufacturers are incorporating radiation shielding and backup systems into their designs to increase the resilience of these critical assets in space. And communication companies are exploring alternative communication technologies, such as fiber optic cables, which are less susceptible to solar storms than satellite and radio-based systems. These efforts, while ongoing and constantly evolving, are crucial steps in safeguarding our technological civilization against the unpredictable whims of the sun. But individual preparedness is just as important. Consider investing in a hand crank or solar-powered weather radio to stay informed during power outages. Keep your mobile devices charged and have backup power sources like portable power banks available. Stock up on non-perishable food, bottled water, and essential medications. And have a plan for how you and your loved ones will communicate and stay safe during an extended power outage. Section 3. Knowledge is power. In the face of the sun's immense power, it's easy to feel small and vulnerable, but we're not powerless. Knowledge is our greatest asset. By understanding the science of space weather, staying informed about solar activity, and taking proactive steps to prepare, we can mitigate the risks posed by solar storms and build a more resilient future. Remember, the sun is both our life giver and a potential disruptor. It's a force to be respected, not feared. By embracing a spirit of preparedness, we can continue to benefit from the sun's life-giving energy while safeguarding ourselves against its occasional outbursts. Stay curious, stay informed, and stay prepared. The future of our technological civilization may depend on it. Section 1. A force to be respected. As we've journeyed from the sun's fiery heart to the delicate circuits of our technological world, one thing remains abundantly clear. The sun is a force to be reckoned with. It's both our life giver and a potential disruptor, a celestial paradox that has captivated humanity for millennia. We've marveled at its beauty, built myths around its power, and even harnessed its energy to fuel our modern world. But the sun, in its raw, untamed glory, reminds us that we are but tenants on this pale blue dot, beholden to the whims of a star we can barely comprehend. The solar flares we've explored, those sudden bursts of energy that ripple across the vastness of space, are not acts of malice, but the natural rhythm of a star in constant flux. Like a sleeping giant, the sun occasionally stirs, sending tremors through the fabric of space-time that can be felt here on our tiny planet. These events, while potentially disruptive, are also a testament to the interconnectedness of the cosmos, a cosmic ballet that links our fate to that of a star millions of miles away. The sun's power is not to be feared, but respected. It's a force of nature like the wind and the waves that shapes our world in ways we're only beginning to understand. Section 2. Guardians of our fate. In this age of technological marvels, where satellites crisscross the heavens and power grids span continents, we've never been more vulnerable to the sun's capricious nature. A major solar storm, like the Carrington Event of 1859, could plunge our interconnected world into chaos, disrupting communication networks, crippling power grids, and jeopardizing the very fabric of our modern way of life. But we are not helpless bystanders in this cosmic drama. We are the guardians of our fate, armed with the knowledge and the tools to prepare for the inevitable day when the sun next unleashes its fury. From the space weather sentinels that keep a watchful eye on the sun's every move to the engineers working tirelessly to harden our critical infrastructure, we are building a more resilient future, one that can withstand the occasional tantrums of our nearest star. We're developing early warning systems, crafting mitigation strategies, and educating the public about the importance of space weather awareness. Every solar storm, every close call teaches us valuable lessons about the interconnectedness of our technological world and the importance of preparedness. The challenge before us is not to tame the sun, but to live in harmony with its rhythms. Announcement 7. Rule 3. Must leave a comment. What you thought about this video and what you would like to see. As we look to the future, our relationship with the sun will only deepen. We'll continue to rely on its energy to power our homes, fuel our industries, and explore the cosmos. But we'll do so with a newfound respect for its power and a commitment to safeguarding our technological civilization from its occasional outbursts. The quest to understand the sun is far from over. Scientists are constantly pushing the boundaries of knowledge, using ever more sophisticated instruments and computer models to unlock the secrets of our nearest star. We're learning more about the sun's internal structure, its magnetic field dynamics, and the complex processes that drive solar flares and coronal mass ejections. These discoveries, in turn, will lead to more accurate space weather forecasts, giving us more time to prepare for and mitigate the impacts of solar storms. The future of space weather forecasting lies in a global network of ground-based observatories, space-based telescopes, and sophisticated computer models, all working in concert to provide a comprehensive and timely picture of the sun's activity. This interconnected approach to space weather will be crucial in protecting our technological infrastructure and ensuring the safety of future generations venturing beyond Earth's protective embrace. Announcement 8. We will announce 3 winners in an update video. Thank you for watching with SurvivalScope. If you enjoyed this video, please leave a comment and subscribe for more content on solar flares and other fascinating topics. Your support helps us continue to share survival tips, survival gear, and other interesting topics with you, and we appreciate it. Thank you. Together, let's stay safe, stay prepared, and stay resilient. Remember, the sun is not just a source of light and warmth. It's a dynamic and powerful force that shapes our world in profound ways. By understanding its behavior, we can better prepare for its surprises and harness its energy for a brighter future. Join us next time as we delve deeper into the secrets of the universe, one fascinating topic at a time. Until then, keep looking up and stay inspired.